Find the area of the region bounded by the following curves. Set up your integrals with respect to y. Oh, so we're doing something different now. Same idea though. What you're going to do is you're going to find your limits of integration, find them, and then you're going to subtract f of y minus g of y. Those are two different ones. Okay, and then we're going to integrate that with respect to dy. So these are already solved for x. That's good. What I need to do is find out where these guys intersect, and that'll give me the limit of integration. So we're just going to set negative 3 equal to y squared minus 4, add 4, and so 1 is going to equal y squared. Square rooting everything is going to give us limits of integration at positive 1 and negative 1. So positive 1 is going to be a, negative 1 is going to be b, except I have that backwards. So let's set this up. The integral from negative 1 to 1. Now, in my last 4 videos, if you watch them, I was hyper-focused on making sure which one was above and which one was below. I'm not going to do that here. I'm just going to do it. And if I get a negative area, then I get a negative area, and I just have to flip it upside down in the end anyway. So I'm going to take a wild guess and say, I don't know, negative 3 is going to be my upper one, and then I'm going to subtract y squared minus 4 dy. So let's simplify that. That's negative 1, negative 3 minus y squared plus 4 dy. Let's scooch that over here where I have a little bit more space. Negative 1 to 1. Negative 3 and 4 make 1, so I have negative y squared plus 1 dy. Integrating negative y squared is going to be negative 1/3 y cubed. And integrating 1 is going to be just y. And my limits are still going to be negative 1 and 1. So now we plug our stuff in. Negative 1/3 times 1 cubed plus 1 minus negative 1/3 times negative 1 cubed plus negative 1. Now it's just a matter of doing some simplification. Negative 1 times 1 cubed is going to be negative 1/3 rather, times 1 cubed is going to be negative 1/3. Okay, 1 cubed is 1, plus 1, minus negative 1/3 times negative 1/3 cubed is going to be negative 1/3 times negative 1, which is positive 1/3. And then I'm going to have minus 1. Like so. U become 2/3 minus u become negative 2/3. So the double negative makes it a positive, and the whole thing becomes 4/3. So that is how you do it. So I chose correctly by assuming that negative 3 was the quote-unquote f of y higher one. But yeah, that's how you do it, and boy did we have fun. Find the area of the region bounded by the following curves. Set up your integrals with respect to y, which means these guys have to be solved for x. Well, you're solved for x. You're not. What I'll do is I'll do two things at the same time. I'll add x and subtract y, and by doing that, you become x equals 2 minus y. No harm, no foul. Okay, then we also have y equals 0. That's going to serve as a limit of integration. Now, what we also don't have is the other limit of integration. So the way I'm going to find my limits of integration is I'm going to set these guys equal to each other. Okay, I'm going to say y equals 2 minus y. If I add if I add y to both sides, that becomes 2y equals 2. Divide both sides by 2, and y equals 1. So my limits of integration are going to be 0 and 1. So we set up our integral. All right, and now the general equation for this is from a to b, the integral from limits of integration a to b of f of y minus g of y. Now normally I hyper-focus on which one of these is the higher graph, but I'm not going to do that here. If I end up with a negative area, I'm just going to make sure I turn it positive. We'll see what happens. I'm not scared of anything. But what I do have is I have the fact that my limits are now 0 and 1. That was a close one. 0 and 1. I'll call f of y, I don't know, x. Not x, y. Minus 2 minus y, close it, dy. Let's simplify that a little bit. Okay, y minus 2 plus y dy is going to be 2y minus 2 dy. Now let's integrate that. The integral of 2y is just y squared, and the integral of negative 2 is negative 2y. Your limits of integration are still 0 and 1. So let's plug stuff in. We get 1 squared minus 2 times 1, close it, minus 0 squared, how nice, minus 2 times 0. That gives us here 1 minus 2 minus nothing. 1 minus 2 is negative 1. Now again, I was worried that this would happen. I guessed wrong by choosing y as f of y. No big deal. All we have to do is flip-flop it, and we get 1. And so the answer is A, 1 square unit. Baby. Find the area of the region bounded by the following curves. Set up your integrals with respect to y, which means we have to have these as x equals something. Well, Chekarooski, you're already good. You ain't. So in order to make that x equals something, I have y equals the square root of x. No big deal. Let's just square both sides. And that gets us x equals y squared. Now, whenever we're finding the area between two curves, we use the formula, the limits of integration from f of y minus f or g of y dy. I don't know my limits of integration, but the way I find my limits of integration is I take that guy and set it equal to each other. So let's set it up this way. Y squared equals y plus 12. Let's subtract y, subtract 12, subtract y, subtract 12, and that gets us, you are gone, y squared minus y minus 12 equals nerfing. Now this does factor out to y minus 4, y plus 3 equals nothing, and that gives me y values at 4 and negative 3. Now when I set up my integral, I'm not going to go too crazy as to figuring out what f of y is and what g of y is, because what's going to happen is if I get a positive area, I'm good, and if I don't, I just make it positive and I'm still good. So I'm going just to do from negative 3 to 4 of y cubed, so this guy right here, minus y plus 12. So we're going to set it up that way, dy. All right, distribute that negative. We have the integral of y squared minus y minus 12. And now I can integrate. And that will be integrate when I do it. Okay, negative 3 to 4. Nope, I'm not doing that because I'm now integrating. See, I got hung up on my own joke. I screwed up. You become 1/3 y cubed. You become negative 1/2 y squared. And you become minus 12y. Okay, limits are at negative 3 and 4. Now it's just a messy math problem. All right, so 1/3 4 cubed minus 1/2 4 squared minus 12 4 minus 1/3 negative 3 cubed minus 1/2 negative 3 squared minus 12 times negative 3. All right, 1/3 times 64 minus 1/2 times 16 minus 48 minus 1/3 of negative 27 minus 1/2 of 9 plus 36. Ugh. 64 over 3 minus half, so minus 8 minus 48 minus 1/3 of negative 27 is negative 9 minus 9 over 2 plus 36. So let's just keep going. We've got 64 over 3 minus 56 minus negative 9, that's 27 minus 9 over 2. So let's move this up here. Do I need to? Do I need to? I kind of do. Let's move this up here where I have a little bit more space. You are going to become 64 thirds minus 168 thirds minus 42 halves minus 9 halves. Okay. 64 minus 168 is negative 104 thirds. Does that simplify? 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 No, it does not. Minus 45 halves. All right. So let's make this over 6, and then we're almost home. We're almost home. So if I multiply the top and the bottom by 2, I get negative 208 over 6. Minus, if I multiply the top and the bottom by 3, 135 over 6. And you're going to be a negative 343 over 6, which means we chose wrong. It's actually positive. So we'll just get rid of that because we are out of room. Holy crap. I did not like that at all. And I hope we did it right. And if I didn't, just tell me in the comments. You guys do that anyway, so I hope it helps.